This video goes over question 11 of the Quadratic Functions assignment. We found that the marketing research department for a company that manufactures and sells memory chips for microcomputers established the following price, demand, and revenue functions. P of x, so this is the demand curve, is 110 minus 4x. Then the revenue function is x, which is the demand, times the price. So that kind of makes sense. So the number that you're selling is x, the price is p, so that's the revenue. And then it comes out to x times parenthesis 110 minus 4x. If we distribute that x inside, we're getting negative 4x squared plus 110x. So that's going to be a downward-facing parabola. So P of x is the wholesale price in dollars at which x million chips can be sold, and revenue is in millions of dollars. Both functions have a domain of 1 to 22, including the endpoints. So in calculus terms, that's called a closed interval. So we do need an up or downward facing parabola. So this one makes sense, and the domain looks like it's 1 to 22. Upward facing parabola, no way. Now this one's a downward facing parabola, but we've got negative x values, so that would be buying chips back. So we can say that this has got to be the revenue function. And we only get one chance, so we'll go ahead and click that. So it's worth talking about exactly how this works. So I've already put in the price function, price demand function. Here it is. I'm going to hit enter, and I don't see anything. And that's because we have the standard viewing window, and we already were told that the domain goes from 1 to 22. So I'm going to put in 0 to, I'm actually going to go ahead and take this out to where I can see the x-intercept. So if we do 110 divided by 4, that's going to be somewhere a little bit more than 25. So I'm going to go to 30 and put a tick mark every 2. And then I'm kind of anticipating looking at the revenue function. So I'm going to go 0 to like 1500 by hundreds. So we can see that we do have the demand function here, and it starts at 110 and then goes down. Now the domain only goes out to, I think, 22, so it would stop here. So now I'm going to put in the revenue function, so that's x times parenthesis 110 minus 4x, enter, and I get a nice downward facing parabola. Maybe have a little bit too much y space, but the thing that the book is asking next is find the output that will produce the maximum revenue. So we're going to go here, menu, analyze graph. I want a maximum. I've got 2 graphs showing, so the calculator's saying graph. So I just go touch and click on the one that I want. Lower bound, upper bound. So 13.75 is the supply level that we want to maximize revenue. So I'm going to go put that in, 13.75, check answer. Oh no, I'm pretty sure that's the right answer. Type an integer or fraction, simplify your answer. So didn't read the fine print. So I'm going to go back to the calculator, add a calculator page, 13.75, menu, number, approximate a fraction, so 55/4 is what they want, even though nobody in business would talk like that. So we'll go up here. Okay, fraction, 55/4. Final check. Excellent. What is the maximum revenue? So we want the y coordinate at that maximum point. So that's 756.25 million. This time I'm going to make sure I read the round to 2 decimal places. Why is it now round to 2 decimal places? 756.25. 756.25. Check answer. Fantastic. What is the wholesale price per chip that produces the maximum revenue? Now, we already put in the price function, so I'm going to go to the calculator, go var, price is F1, that's my demand for max revenue. So my price is 55. Check answer. Fantastic. And that concludes this video.